So far, the trig functions we have been looking at have been sine, cosine, and tangent. Well, really, there's three more trig functions, and they're the reciprocal functions of sine, cosine, and tangent, called cosecant, secant, and cotangent. Now, it's important that you know the relationship between cosecant, secant, and cotangent with sine, cosine, and tangent. So start off with cosecant. So cosecant is the reciprocal of sine, and that's why you can see it here as 1 over the sine of theta. When looking at it in regards to a right triangle, sine of theta is the opposite over the hypotenuse, but because cosecant is the reciprocal of that, that's why cosecant is the hypotenuse over opposite. Reciprocal meaning, flipping the fraction. We then also have secant. Now, secant is the reciprocal of cosine, and so again, you can see how it's 1 over the cosine of theta. And again, looking at it as in regards to a right triangle, cosine of theta is adjacent over hypotenuse. So if we flip that, we're going to get secant, which is the hypotenuse over adjacent. Now, this last one, cotangent, I think it's easy to figure out what the reciprocal of that one is, and that's tangent, just because they share part of its name. So you can see it's being 1 over the tangent of theta. And so tangent of theta being the opposite over the adjacent. And so if we take the reciprocal of that, flipping that fraction, we're going to get cotangent, which is the adjacent over the opposite. Now going to our unit circle. Looking at the unit circle, we know that the cosine is the x-coordinate and the sine is the y-coordinate. We also talked about how the tangent of theta is y over x. So if we look at the reciprocals, we want to be able to flip that fraction. So remember, any whole value can be written as a fraction by placing it over 1. So when we flip it, it's going to be 1 over the x value. And secant goes with cosine. So that's why you see them going up and down that vertical. Sine of theta is the y value. Again, you can write any whole number as a fraction by placing it over 1, making it easier for us to see the reciprocal by placing it 1 over the y value. Now, cotangent, we can look at this one of two ways. We can look at it as being 1 over tangent, which would be 1 over y over x. But that's kind of a complicated fraction because you have a fraction over a fraction. But when we're looking at reciprocal functions, really what we can do is just take this fraction right here and flip that. So really the cotangent of theta is the same thing as x over y. Now let's specifically look at an angle on our unit circle and find the cosecant of it. So cosecant of 5 pi over 6. So 5 pi over 6 is in quadrant 2, and the coordinates of 5 pi over 6 is negative square root of 3 over 2, comma, 1/2. Now, cosecant, remember, is the reciprocal of sine. So that means it's going to be 1 over my y value, all right? And my y value is this right here, my 1/2. So I'm going to take my y value and plug it in, so 1 over 1/2. And when you have a fraction over a fraction, you need to multiply by the reciprocal. So this is going to turn into 1 times 2 over 1. Remember, any whole number can be turned into a fraction by placing it over 1. And so when you're multiplying fractions, you multiply straight across. So that's going to become 2 over 1, or just simply 2. Now, another way that you can look at this is by simply just looking at your y value. And since it's a fraction, you can go ahead and flip it using that reciprocal definition. And then when you flip 1/2, it automatically becomes, sorry, not an equal sign. When you flip it, it flips to 2 over 1, which would then be your cosecant of 5 pi over 6. Let's look at one more. So finding the cotangent of 315 degrees. So when we look at 315 degrees in quadrant 4, my coordinate is square root of 2 over 2, comma, negative square root of 2 over 2. So cotangent, remember, the relationship with that is it's x over my y value. So I'm going to go ahead and set up that fraction. So it's square root of 2 over 2 all over negative square root of 2 over 2. Now, when we look at this, I'm hoping that you see that this becomes a huge, giant 1 because the fraction that's in the numerator is the exact same fraction that's in the denominator, except that it's negative. So this is just going to equal a big, gigantic negative 1. Before we can begin looking at the reciprocal trig functions, it's important to know how to rationalize the denominator. So the reason why we rationalize the denominator is because it's easier to see the value of the fraction when the radical symbol is in the numerator. So let's take a look at 2 over the square root of 3. And so to rationalize the denominator, what we do is we multiply both the numerator and the denominator by the radical that is in the denominator. And to do that, when we multiply fractions, we just multiply straight across. So we're going to do 2 times the square root of 3, and that's going to stay 2 times the square root of 3. The multiplication of the whole value stays outside of the radical symbol. In the denominator, because we have 2 values inside of the radical, it becomes square root of 3 times the square root of 3, which ends up being the square root of 9. And we can simplify that further to be 2 times the square root of 3 over 3. Let's take a look at another one. Let's say we are trying to rationalize the following fraction. Five over the square root of 7. Let's make this negative. Okay, so let's say to rationalize this, what we're doing is getting the radical symbol out from the denominator. So we're going to multiply both the numerator and the denominator by the square root of 7. Again, we're going to multiply that straight across, so it's going to become negative 5 times the square root of 7 over square root of 7 times the square root of 7 is the square root of 49. But again, we can simplify that further, being negative 5 times the square root of 7 over 7. Let's take a look at just one more. What if we have 8 divided by the square root of 2? So again, we're going to rationalize this to get the square root out from underneath the denominator by multiplying both the numerator and the denominator by the square root of 2. Then we're going to multiply straight across. So that's going to become 8 times the square root of 2 over square root of 2 times the square root of 2 is the square root of 4. Again, that can be simplified further to be 8 times the square root of 2 over 2. Now, the one thing I want you to notice is that anytime possible to simplify, you're going to want to do that. So this 8 over 2 does simplify to being 4 times the square root of 2, because I would simply just do 8 divided by 2.